Hello, once again. We're looking at rule 2 this time, which is the voltage across the battery. And I'm just going to show you the voltage across a battery. We're using a voltage meter, a voltmeter. It's always placed across a component, so from one end to the other. And there we go, we see it's 9 volts. Okay, now if I link up this series circuit that's got one battery, a series of wires and one bulb, we should see that the current flows in a clockwise direction, yes. If, however, I was to turn the battery round the other way, like so, you can see that the positive end of the battery is now on the left-hand side, the negative side is on the right-hand side, and you can see that the electrons, the negative charges, are flowing in an anti-clockwise direction, allowing the bulb to light up. Now, if I were to cut this series circuit for a second and include another battery, we should see that the current is flowing much faster, and there it is. And of course the bulb will get brighter. Now the whole reason that we are looking at this rule number 2 is the voltage across the batteries, across the power source, and remember it's across the components. What do you think the voltage will be? 18 volts. Now it says negative 18 volts only because the current is flowing anti-clockwise. If I were to turn the batteries round the other way, the current would flow in the opposite direction and we would get a positive 18 volts, and that's exactly what I'm going to do now. Turn the first one round, turn the second one round, and we should now see that the voltage is a positive 18 volts, and there we go. Now, once again, let's go back to the rule that we're looking at. The voltage across the batteries or the power source should equal the voltage around any of the components. Now, if the voltage across the battery is 18 volts, it shouldn't surprise you that the voltage across the bulb is also going to be 18 volts. However, if I now break the circuit down by the bulb and add another bulb, what do you think the voltage across each bulb will be? And what do you think the brightness of the bulb will be? Do you think it will be brighter, it will stay the same, or it will be dimmer? Here we go. They appear to be dimmer. And the voltage across each bulb, remember the voltage across the power supply was 18. What do you think the voltage across each bulb will be now? I'm sure you would have guessed that it was 9 across that bulb. And 9 across this bulb. One last thing. Remember, the rule that we're looking at is the voltage around the power pack from here to here should equal the voltage across one bulb plus the voltage across any other bulbs or components. So if I was to remove the voltmeter, and remember the voltmeter goes across a component, if I were to remove that for just a moment and break the circuit, if I was now to add yet another bulb, I'm sure you'd agree with me that all the bulbs are going to be dimmer. But what will the voltage be across each bulb? Remember, the voltage across the power pack was 18. volts. You can see now that the current has slowed right down. It's because we've got a lot of resistance in this circuit. There's a lot of very thin wire in the filament bulbs there. But once again, what is the voltage across each bulb? 18 volts across the batteries, and that 18 volts is shared between the bulbs. What do you think the voltage across each bulb will be? Let's have a look. See if you're right. And here we go. 6 volts. Because 6 volts plus 6 volts plus 6 volts equals the voltage across the battery, which is 18 volts. It's been shared equally here. Now, that doesn't necessarily hold true on every single occasion. For example, if we've got 18 volts across the power source, the batteries, and we had 6 volts across the left-hand bulb, and we had 10 volts across the middle bulb, what would be the voltage of the right-hand bulb? I wonder if you got the right answer. It would be 18. Take away 6. Take away 10 leaves us with a voltage of 2, because 6 plus 10 is 16 plus 2 is 18, which comes back to the power source. That was rule number 2. The voltage or potential difference, or PD, across the power source must equal all the voltages across all the components added up.